Hello, everybody. So today we're going to talk about percent yield, which is the last section of our stoichiometry notes. So with percent yield, what we're talking about is the efficiency of a reaction carried out in a lab. So how well is a reaction occurring in the lab based off its theoretical and actual yield? So the theoretical yield is based off, in theory, this is how much you should make if we lived in an ideal world. So that is the max amount of product that could be formed from a given amount in a reaction. So this is what we solved during our stoichiometry problems. The actual yield is the amount of product actually formed when it's carried out in a lab. So when we carry out our reactions in a lab, it is never going to match this exactly. And the reason for that is because there's always going to be some sort of error, whether it's human error, machine error, the environment's not right for the reaction to take place as in the perfect ideal world it would be. And so it's never going to be fully perfect. So we want to figure out how close are we getting to being perfect, if we want to think about it that way, or how efficient is this percent yield actually, or this equation or reaction happening. So the percent yield equation is percent yield equals the actual yield divided by a theoretical yield times 100. So again, we're just measuring the efficiency of the reaction being carried out in the lab. How well are we actually doing when we're going through this problem? Now, in your stoichiometry problems, you're going to be given two numbers. One will be your actual, and one is going to be your known. So how do you know which one is the actual and which one is the known? The actual, you're going to see words like wants to make, or intend to make, or is produced, or is formed. Generally, we stick to these two here, is produced or is formed. When it says that verbiage, that's telling you that's going to be your actual, that was actually what was made in the lab. The other number is going to be in theory, or your known, starting to then predict what should be your theoretical yield. So here's an example. What is a percent yield if 4.65 grams of copper is produced when 1.87 grams of aluminum reacts with excess of copper 1 sulfate? Okay, so we're reading through that and you're like, how am I supposed to know which one is my known and which one is my actual? So what is produced in the percent, or what is the percent yield if 4.65 grams of copper is produced? So I see the words is produced, and they're talking about the copper here. So the copper is telling me that is going to be my actual. And it's saying is produced when this reaction takes place, when the aluminum reacts with excess of copper 1 sulfate. Also, I noticed your equation is not balanced. Again, if you have issues with this, please come see me so we can get this figured out. But you should have a 2. It should be 3 copper sulfate with 6 coppers plus 1 aluminum sulfate. So that will be there. So that is your balanced equation. So our actual 4.65 grams of copper, because we see the word is produced. Then we see 1.87 grams of aluminum, and that is going to be our known. So our known in this problem, 1.87 grams of aluminum. Our unknown needs to match the units of our actual. So it would be grams of copper. Grams of copper. Okay, so now that I have my known and unknown figured out, I now need to solve my stoichiometry before I can get into the percent yield equation. So I'm going to start with what I know. I know I have 1.87 grams of aluminum. Draw my train track. And again, since I am in 2 grams, it's going to be a mass-to-mass problem. That means I need to worry about aluminum and copper. So I'm in grams of aluminum to start. I need to put grams of aluminum on the bottom. So that would be 26.98. And again, just got that from my periodic table. Then I'm going to have my 1 mole of aluminum on top. Since I'm in moles of aluminum, I need to get to grams of copper. I keep going. I'm going to have my 2 moles of aluminum on the bottom, so these units cancel out, with my moles of unknown, which would be 6 moles of copper. So my moles of known on the bottom, moles of unknown on top. All from our coefficients. Okay, I'm in moles of copper. I need to get to grams, so I have to keep going. So I'm going to have my 1 mole of copper on the bottom. And I look on my periodic table, copper is 63.55 grams of copper. Okay, now I multiply across the top. I should get 713.031. Multiply across the bottom. I should get 53.96. I divide those two, and I get an answer of 13.214066. I'm still going to put it into sig figs. So I have 3 sig figs here. I have 3 sig figs here. That means I need to go to 3. 1, 2, 3. I look behind. It's a 1. So I'm going to stay the same. I have 13.2, and it would be grams of copper. Okay, so that is my theoretical. So, close enough. So my theoretical, we'll just call it my theory. There we go. So theoretical would be 13.2 grams of copper. My actual, we said, was 4.65 grams of copper. From the problem, now we can solve. So percent yield equals, and again, it's actual over theoretical times 100. So my actuals from the problem, 4.65 grams of copper. Divide that by my theoretical, which I just found over here, which would be 13.2 grams of copper, times 100, because we're making it into a percent. When you go through the math, and I would go probably 1 decimal place, it would be 35.2%. So the efficiency of your lab was about 35%, because compared to these numbers, there's a pretty big gap based off what you actually made compared to what you should have. So you're about 35% for your efficiency, which is not great, but again, there's a lot of error that can occur. Okay, so major things to take away. Actual. If you see the word is produced, look what's in front of it. Then the rest would be your known. Make sure your known or your unknown matches the actual unit. Solve your stoichiometry problem as per usual, and then plug it into your percent yield problem. All right, let's do another one. Okay, so in an experiment, 170.9 grams of C2H4 was reacted with an excess of oxygen. 164.1 grams of carbon dioxide is produced. What is the percent yield? Okay, so like we talked about before, is produced is your dead giveaway that is going to be your actual. So this is your actual. I like to label mine so I don't forget which one's which. So my 164.1 is my actual. My 170.9 is my known. My equation's already balanced for me, so I can just get into my known and my unknown. So my known, again, 170.9 grams of C2H4. And again, I know that because my actual says the words is produced. So the words is produced is the big hint for my actual. My unknown needs to match my actual units. So my actual's units is grams of carbon dioxide, CO2. These need to match your unknown and your actual for their units. Okay, we start these like all of our stoichiometry problems we have. So we start with what we know. So 170.9 grams of C2H4. Draw your train track. Okay, so I'm in grams of C2H4. I need to have grams of C2H4 on the bottom. Now, we need to solve for that by solving for the molar mass. So, carbon is 12.01 from our periodic table. And there are 2 of them in the compound. So you multiply that by 2, you get 24.02. Hydrogen is 1.01 times 4, because there's 4 of them in the compound, you get 4.04. Add those up, you should get 28.06. So we're going to take that 28.06 that we just found, plug that into our molar mass for our grams. Okay, so we're switching from grams to moles. That means I'm going to have 1 mole of C2H4 on top. Okay, I'm in moles of C2H4. I need to keep going because I need to get to grams of carbon dioxide. Okay, my coefficients. I'm going to switch from moles of known on the bottom to moles of unknown on top. My known is C2H4. My unknown is carbon dioxide. So I'm going to have 1 mole of C2H4. I am also going to have 2 moles of my unknown, so my CO2. Again, all coming from the coefficients there. So now I'm in moles of unknown. I need to get to grams of unknown. So I have moles from the top. I need to have my 1 mole of carbon dioxide on the bottom. And then I need to solve for what is the molar mass of carbon dioxide. So I solve for molar mass. Carbon, we said, was 12.01. We're going to multiply that by 1 because there's only 1 in the compound. We get 12.01. Then we have oxygen, which is 16. We're going to multiply that by 2 because there's 2 of them in there. And you should get 32. We're going to add those 2 up. You should get a molar mass of 44.01. So we're going to take that 44.01, and that would be our grams of carbon dioxide. Okay, so now that I'm in grams of carbon dioxide, we solve. So I multiply across the top, 170.9 times 1 times 2 times 44.01. You should get 15042.618. Divided by, multiply across the bottom, you should get 28.06. Divide those 2, you should get an answer of 536.08763. Okay, I need to put it into sig figs. My known is 1, 2, 3, 4 sig figs. Same thing with my actual, so I'm going to go to 4 sig figs. 1, 2, 3, 4. Look behind, it's an 8. So I'm going to round up. So it would be 536.1. And again, my unknown is in grams of carbon dioxide. Okay, so that is my theoretical yield. So in theory, if everything went correctly, I should make 536.1 grams of carbon dioxide when I mix it, or when I mix oxygen with C2H4. So that's how much I should make. Okay, now we have to go into our percent yield. So percent yield. So again, it's our actual divided by theoretical times 100. So our actual, we said, was the 164.1 grams of carbon dioxide. We're going to divide that by what we just found. So our 536.1 grams of carbon dioxide times 100. And when you do that, you should get an answer of 30.6%. So overall, not a great turnout, but it is about 30% effective. Another way you can check, if your actual units do not match your units at the end or your theoretical, something went wrong and you used the wrong number as your known or unknown. Okay? So always double check that. Again, the major thing is find the word is produced, is formed, any of that kind of verbiage, and then look behind it, and that's going to tell you what your actual is. And that won't be used till the very end for just this section only. Then you use the other number as your known. Make sure your unknown matches your actual's units, and then solve per usual, and then go from there. Most of these, 99%, are going to be mass-to-mass problems. So we should know how to solve for molar mass and all that by now. So try your best on the homework. I know it's tricky. You can work with the people around you if the sub says it's okay, but just try your best. I will be back on Monday, so if you have any questions, just let me know, and I will try and get back to you as soon as possible. I will be there early Monday morning, so feel free to stop by and get some help if you need it. Alrighty, your percent yield worksheet is due on Monday, so let me know if you have any questions. Try your best. I believe in you. Have a great rest of your day, and see you